would go up there, so because that's 15, and they're starting to keep track by subtracting down here and keep track of what their quotient is up on top. So 15 and 1/3 starts to look like the answer. This again is it's just the expanded form of the division algorithm. Expanded because the quotient is expanded upward like this. And if you have a really large number, let's say you have, I don't think I have an example here, but I'll make one real quick. Let's say that I have, let's say it's 5 into 2,438. You teach students that you can really start to guess your way through this. So how many 5s, if you're not sure how this works, you don't know how the long division algorithm works yet, but you want to understand that you're subtracting 5s from it. Well, you might say, well, I could take away 100 5s, because that's 500, and so you'd line 500 up here. 8, 3, 24 minus 5 is 19. 1930, you could say, well, I could take away another 100, because that'd be 500 more. And then say, wait a second, if I took away 200, that's taking away 1,000. So they put 1,000 underneath here. And you've got 8, 3, 9. 9 and 38, well, we could take away 100 again, and that would take away 500 like this. And what happens is you're teaching kids that to have the confidence that they're subtracting downward and just keeping track of the number of things they're subtracting on top. You could have any number of factors basically up on top that are factors of 10 like this that you're using to develop things you're subtracting. And eventually when you assemble these all back together, it will be the same as if you had done the division algorithm to create that answer. So I don't know if I want to quite write over all of this. The next thing that we do after we start to say, okay, this doesn't make as much sense because it's getting longer on top, and it would be nice to have one that's concise and answers in that traditional way. Then I demonstrate, I call it endless division strategy, and it's this really long division problem just to develop the idea of how it is you do long division. So I have students in class put in a bunch of digits. And we don't really mind whichever ones they want. We just fill it all out like this all the way across. And then one by one I would call out on students, and we would practice doing traditional division in this long division form on this page like this. And it just reinforces what that algorithm looks like. The reason why I use such a long one like this is that if students only see really short division problems, sometimes they don't rehearse the subtraction steps underneath it enough times to really develop the habit of writing down something and subtracting and keeping track of the number of times you're doing it up here, dropping, going like this, and just this whole manner of making the algorithm work like this. They don't have enough practice unless it's long and continuous, and so that's why the endless division strategy works pretty good. And finally, we get around to using the standard algorithm for division in class. And I just wanted to share this as an example to students and families about how, especially if you missed this worksheet, how I've been teaching these concepts in class. The goal is, of course, understanding the long division standard algorithm.